Hello, in this video we'll be working through Unit 6 homework problems 46 through 55. For 46 we want to find g prime of x. So g of x is an integral, and we want to find the derivative of this integral. Well, the derivative of the antiderivative, those are inverse operations, so they're sort of going to cancel each other out, but since it's a definite integral, if we think about the long way to do this problem, we would integrate 2t plus 3, and then we would evaluate it from 2 to 3x. So we'd have to, once we find the antiderivative of 2t and the antiderivative of 3, we would sub in the top value, 3x, minus, and then we would sub in the bottom value, 2, and that would just be our integral. Then we'd have to take the derivative of all of that. And so the derivative is going to end up undoing the antiderivatives. So the shortcut here is we're going to go ahead and substitute our upper limit of integration in for t, and then multiply by the derivative of this upper limit. So we get 2 times 3x plus 3. That's what I get when I substitute my 3x in for t. And then we have to multiply that by the derivative of 3x. So we're going to multiply all that by 3. Minus, and now I'm going to substitute in my lower limit of integration in for t, and then multiply by the derivative of that lower limit. But the derivative of 2 is 0. So I don't really need to show the work here because it's just going to end up, that second term is just going to end up being 0. But if I did want to show the work, it would be 2 times 2 plus 3, and then all of that gets multiplied by the derivative of 2, which is 0. So that term just goes to 0, leaving me with a final answer of, let's see, we've got 2 times 3x is 6x, times 3 is 18x, and then 3 times this 3 out here, so I had to distribute the 3 to the 2 times 3x and to the 3. So 18x plus 9 will be my final answer. Number 47, find h prime of x if h is the integral of 3 root t dt from negative 2 to x to the power 4. So we're going to use this shortcut. I'm going to take my upper limit of integration and substitute that in for the t. Okay, then I'm going to multiply by the derivative of x to the 4th. So I get 3 times the square root of x to the power 4 times the derivative of x to the power 4, which is 4x cubed, minus, and then when I substitute the negative 2 in and then multiply by the derivative of negative 2, that part's just going to be 0. So minus 0. And if we simplify this, we get 3 times 4 is 12x cubed times the square root of x to the power 4, which is x squared. And so we can write our final answer as 12x to the power 5. Number 48, find f prime of x if f is the integral of t squared plus 2t dt from 2x to negative 1. So this time my upper limit of integration is constant. If I sub in negative 1 for my t's and then multiply by the derivative of negative 1, I just get 0. So my first term is 0. Minus, and then we have to do this for the lower limit of integration. We're going to substitute 2x in for t and then multiply by the derivative of 2x. So we have 2x going in for t, and t gets squared, plus 2 times t, and we're subbing 2x in for t. All of that is being subtracted, so I have to be careful there about distributing my negative sign. And then that gets multiplied by the derivative of 2x, which is 2. So simplifying here, inside my parentheses, I have 4x squared plus 4x, and all of that needs to be multiplied by negative 1 and by 2. So in other words, multiplied by negative 2, giving me negative 8x squared minus 8x. Number 49, we want to find h prime of x if h is the integral of 2t squared dt from negative 5 to cosine x. So we're going to sub in our upper limit of integration in for the t and then multiply by the derivative of cosine x. Oh, I just realized I've been using equal signs, but really it's not this integral that is equal to my answer, it's the derivative. So overlook that on the last couple examples. H prime of x equals. Okay, so we're subbing in the cosine x for the t. So 2 cosine of x times cosine of x is cosine squared x. And then we have to multiply that by the derivative of cosine x. The derivative of cosine x is negative sine x. I'll move the negative to the front. And then minus, now when I sub in the bottom and multiply by the derivative of the bottom, I'm just going to get 0. So just minus 0. We don't have to worry about that part. So we've got negative 2 cosine squared x sine x. Number 50, we want p prime of x if p of x is the integral 3t minus 2 dt from 2 to x squared plus 2x. So p prime of x is going to be, now we want to sub in x squared plus 2x in for the t, and then multiply by the derivative of that. So 3 times x squared plus 2x minus 2, all of that gets multiplied by the derivative of x squared plus 2x, which is 2x plus 2, minus 0, since the derivative of the lower limit is 0. So we can ignore that part. Okay, so let's simplify within these first brackets first. I've got 3x squared plus 6x minus 2, and that needs to be multiplied by 2x plus 2. So let's, I mean, this isn't the only way to do it, but I'm just going to distribute the 2x by the trinomial at the beginning. So that gives me 6x cubed plus 12x squared minus 4x. And then I'm going to, oh, this is actually what I did there. And then I'm going to distribute the 2 here, here, here. So I get 6x squared and then plus 12x and minus 6. And then I combine all of the like terms and I get 6x cubed plus 18x squared plus 8x minus 6. Not minus 6. Minus 4, because 2 times negative 2 is negative 4. And then number 51, we want f prime of x if f is the integral of e to the t plus t dt from ln x to 2. So when I substitute in my upper limit of integration and then multiply by the derivative, I get 0 on the top. So f prime of x equals 0 minus, and then I do that for the bottom. I sub in my ln x in for each of these t's, and then I'm going to multiply by the derivative of ln x. So I get e to the ln x plus ln x, and that has to get multiplied by the derivative of ln x, which is 1 over x. Now e to the ln x is just x. This right here is just equal to x. And we need to distribute the negative. I'll do it in 2 steps. We need to distribute the negative. So negative x minus ln x. That has to get multiplied by 1 over x. And now distribute the 1 over x. So I get negative 1 minus ln x over x. 52, let g of x equal the integral of t cubed e to the t dt from 0 to x. We want to find g prime of 1 and then g double prime of 1. So first let's find g prime of x. G prime of x is the derivative of the integral. So we can use our shortcut to take the derivative of the integral where we substitute in the upper limit of integration in for the t. So that would be x cubed e to the x. Then we multiply by the derivative of that upper limit, which is just 1, minus, and then we do the same thing for the lower limit, but that's just going to be 0. When we multiply by the derivative of 0, we get 0. So g prime of x is x cubed e to the x. And that means g prime of 1 is just 1 cubed times e to the 1, or just e. Now g double prime of x, I have to take the derivative of g prime of x, and to do that, I'll need to use the product rule. So I take the derivative of the first times the second plus the first times the derivative of the second. There's my equation for g double prime of x. And then for g double prime of 1, I just sub 1 in for x. So 3 times 1 times e to the power 1 plus 1 cubed times e to the power 1. And 3e plus e is 4e. So g double prime of 1 is 4e. Number 53, let h be the integral of square root of 1 plus t to the fourth dt from x squared to 2. We want to find h prime of x and then h double prime of 1. H prime of x is the derivative of that integral. So to take the derivative of the integral, I'm going to sub in my top number and then multiply by the derivative of the top number, which is 0. So that's going to just cancel out. And then minus, and I'll do the same thing using that bottom number. So I substitute the x squared in for the t. I get square root 1 plus x squared to the fourth. X squared raised to the power 4 is x to the power 8. And then I have to multiply by the derivative of the x squared, which is 2x. So this is negative 2x times the square root of 1 plus x to the power 8. And then h double prime of 1, before we find that, we have to find h double prime of x. So I'm taking the derivative of h prime of x, and I have to use product rule again for this one. So derivative of the first is negative 2 times the second, square root of 1 plus x to the 8th, plus the first times the derivative of the second. The derivative of square root of stuff is 1 over 2 root stuff times the derivative of the stuff, so times 8x to the power 7. And we can simplify this, but ultimately I'm looking for h double prime of 1, so I'm just going to go ahead and put the 1 in now and simplify later. So negative 2 times the square root of 1 plus 1 to the power 8, so negative 2 root 2, minus, now x is 1, so in the numerator I have really just negative 2 times 8, which is minus 16, but then I'm going to divide that by 2, so I get minus 8 over the square root of 2. And we can leave our answer like that, or we can try and simplify. So we have negative 2 root 2 minus, if I multiply the top and bottom by root 2, and normally I wouldn't bother rationalizing a denominator, but in this case, since there's a root 2 in the other term, if I do rationalize my denominator, I think these are going to become like terms and I'll be able to simplify. So that's the only reason I'm doing this. Okay, so then on the top I have negative 8 root 2, and on the bottom we'll have 2, and 8 divided by 2 is 4, so that's going to leave us with minus 4 root 2. And negative 2 root 2 minus 4 root 2 is negative 6 root 2. Number 54, we have the graph of little f of t, and the integral of little f from negative 6 to 2x is given by big F of x. So in part A, we want to find big F of 0. So big F of 0 is going to be, we're just going to substitute 0 in for x in the equation for big F of x. So we get the integral from -6 to 2 times 0, or just 0, f of t dt. Now this integral, since we don't have the equation for little f of x, we can find using the graph of little f of x. The integral from -6 to 0 is the area under the curve from -6 to 0. So from -6 to 0, we need this area here from -6 to -2, and then this area from -2 to 0. So this is, it looks a little bit warped, but from -6 to -2, we have half of a circle with radius 2. So the entire circle would have an area of 4 pi. We only want half the circle, so the area is 2 pi, and it's below the x-axis, so the area is actually -2 pi. And then our triangle is half of a 2 by 2 rectangle, which has an area of 4, and half of that is 2. So we have a positive 2 here. So that is going to equal -2 pi plus 2, or 2 minus 2 pi. Now f of -1/2. For f of -1/2, we need the integral from -6 to 2 times -1/2. 2 times -1/2 is -1, so we're going to integrate from -6 to 1, little f of t dt. So this is the area between -6 and -1. So we already said from -6 to -2, that area is -2 pi. And now we need to go from -2 to -1. Well, that's half of a 1 by 1 rectangle, so the area here is 1/2. And it's positive since that area is above the x-axis. So this will be 1/2 minus 2 pi. Part C, find big F prime of -2. So first let's find big F prime of x. Big F prime of x is the derivative of the integral. So we sub 2x in for the t and then multiply by the derivative of the 2x. So we get f of 2x times the derivative of 2x, which is 2, minus, and then we do the same thing for the lower limit of integration, but when we multiply by the derivative there, we're going to get 0. So it's just f of 2x times 2. So if I want f prime, big F prime of -2, I'm going to get little f of, and letting x equal -2 gives me a -4 inside my parentheses, times 2. F of -4, since we have the graph of f of t, now I can just read f of -4 from the graph. At -4, the y-coordinate is equal to -2. So this is -2 times 2, or -4. So f prime of -2 equals -4. Big F prime of 2.5. So we've already done the work for finding the equation for big F prime. We just have to sub in 2.5 for x. So now it's f of 2 times 2.5, which is 5, times 2. F of 5, we read from the graph, f of 5 is 2. So 2 times 2, and that's going to give us a positive 4. Now f double prime of 0, we'll find by finding f double prime of x first. Big F double prime of x is the derivative of big F prime of x. And to take the derivative of big F prime, we need to use the chain rule and the constant multiple rule. So the times 2 is still going to be times 2 when I take the derivative, but the f of 2x, that's f of stuff. So when I take the derivative, I get f prime of the stuff times the derivative of the stuff. So I actually end up with 4 times f prime of 2x. And then f double prime of 0, we're just going to substitute 0 in for the x, would be 4 times f prime of 0. F prime of 0, little f prime of 0, is the slope of f at 0. So the slope right here is positive 1. So this is just 4 times positive 1, or 4. And our last problem, 55, here again we have the graph of little f of t. And g of x is defined as the integral of f of t dt from negative 2 to x. So to find g of 3, we simply replace the x with a 3, and we get the integral from negative 2 to 3 f of t dt. So to find the integral of f, we find the area under the curve f from negative 2 to 3. So negative 2 is here, 3 is here. We're going to find that area. So we've got a little triangle here that has an area of positive 1. But then we have this triangle here with an area of negative 1. So as we find our accumulated area, those two areas cancel each other out. And then we have, let's see, I'll split this here. So this is forming a trapezoid, or we can say that's a rectangle with an area of 2 plus this triangle with an area of 1, half of a 2 by 1 rectangle. So altogether that part is 3. Between 0 and 1, the area is 3. And then over here, if I find this 2 by 4 rectangle that has an area of 8, but then I want to subtract out a quarter of this circle. This is a circle with radius 2, so the whole circle has area of 4 pi. I only need 1/4. So pi is the area in this quarter circle here. Okay, so if we're keeping a running total, then we have 3 plus 8 minus pi. So it would be 11 minus pi. Oh, wait. I'm not considering that that's below the x-axis. I think it'll actually be the opposite of that. So my area of 3 is actually an area of negative 3. And my 8 is really a negative 8. And we have to take away the pi from that. So it's going to make it plus pi. If you imagine just flipping everything across the x-axis, that would have been the 3 plus 8 minus pi. So we need the opposite of that. Negative 11 plus pi, or pi minus 11. Part B, find g of negative 4. So now we need the integral from negative 2 to negative 4 f of t dt. From negative 2 to negative 4, we're actually going backwards with this integral. We're going backwards. So we have to use the opposite sign on our area. From negative 2 to 4, if it was from negative 4 to 2, and maybe that's an easier way to think about it, we can go ahead and flip our sign. I can say, the integral from negative 2 to negative 4 f of t dt is equal to the opposite of the integral from negative 4 to negative 2. And then now I'll just find my area like I normally would. So above the x-axis, positive area. So this piece right here is 2 plus 1, 3, and then this is symmetric over here, so it's also 3. So we get a final answer there of negative 6. Part C, we want g prime of negative 2. So let's find g prime of x. G prime of x is the derivative of the integral. So I take my upper bound, I substitute that in for t, and that gives me f of x. Then I multiply by the derivative of the upper bound, which would just be 1, minus, and then I do the same on the bottom, but the derivative of negative 2 is 0, so that's just going to become 0. So g prime of x is just little f of x. Then g prime of negative 2 is f of negative 2, and I can read that right from the graph. F of negative 2 is 2. g double prime of negative 5. Well, g double prime of x is the derivative of g prime, so that's just f prime of x. And g double prime of negative 5 then is f prime of negative 5, or the slope of f at negative 5. So right here, what is the slope? We can just use rise over run. We go up 2 over 1, so the slope there is 2.